Alright, so this question says the time between seeing a lightning flash and hearing the thunder it creates varies directly with how far away the lightning is. So if you're further away from lightning, it's going to take longer for you to hear the sound that comes with the flash. The thunder from a lightning flash 685 meters away was heard after 2 seconds. So we have to create an equation that relates how the time before hearing the thunder and the distance from the lightning flash. So I've done that. We also have to graph the relationship. I've done that as well. So to create the equation, we're going to let y represent our distance in meters, and we're going to let x represent our time. So we get an equation, a y equals mx plus b equation. Now, y equals m. What is our slope? Well, it's 685 meters over 2 seconds, because that is the relationship that is constant. We're finding out how fast it travels. Y equals 685 over 2x, which equals y equals 342.5x. So that's our slope. It is a direct variation. Now to graph this, I have my y-axis shows the distance, and my x-axis shows the time it takes. So after 1 second, it takes 342.5. After 1 second, it travels 342.5 meters. So that's somewhere around there. After 2 seconds, 685 meters, which is somewhere around there, and so on. And it just goes up and up and up.